Hello and thank you for watching my video. My name is Astrid Krasniji. Today we are talking about static routing. CCNA Semester 2, Chapter 6, Static Routing. Objectives for this lesson is to explain the advantages and disadvantages of static routing, explain the purpose of different types of static routes, configure IPv4 and IPv6 static routes by specifying a next hop address, configure an IPv4 and IPv6 default route, configure an IPv4 and IPv6 summary network address to reduce the number of routing table updates, and configure a floating static route to provide a backup connection, explain how router process packets when a static route is configured, and troubleshoot common static and default route configuration issues. Reaching remote network. A router can learn about remote networks in one of two ways. First is manually. Remote networks are manually entered into a routing table using static routes. Administrator will go to the router, will start typing a static route. Or router can learn them dynamically. Remote routes are automatically learned using a dynamic routing protocol, such as RIP, EIGRP, OSPF, and so on. There are some advantages and disadvantages of both static and dynamic routing, but we'll see the static routing advantages. The advantages of static routing is that static routings are not advertised over the network, so resulting in a better security. The second advantage is static routing or static routes use less bandwidth than dynamic routing protocols. No CPU cycles are used to calculate and communicate routes. The third advantage is the path a static route uses to send data is known. So we have three really big advantages. First is security, much better security because we're not advertising to our neighbors. The second is that we're saving on the CPU or memory power processes. Then we know the path the static route is gonna, or the route or the packet is gonna flow. Disadvantages of static routing is that initial configuration and maintenance is time consuming. That's a big disadvantage. For example, if we have to first configure like 10, 15, 20 routes, static routes, and maintain them, it will be a big time consuming. Then configuring is error prone, especially in large networks. So as soon as we start entering static routes, even though if we have not many, 20, we might start making mistakes, so it's error prone. Administrator intervention is required to maintain changing route information. So every time a route goes down or comes back up, we have to go to each router that's working as a static routing and update it. Does not scale well with the growing networks. Maintenance becomes cumbersome. It's true. As soon as we have to add few more networks, we have to go to each individual router and update that routing table. Requires complex knowledge of the whole network for proper implementation. Sorry, not complex, complete. Requires complete knowledge of the whole network for proper implementation. Now you need to know pretty much everything, all the packets, the way they're going to travel, for you to properly implement the static routing. Today's network, it's hardly you will know everything, all the network. Static routing applications. Static routing has three primary uses. So providing ease of routing table maintenance in small networks, they are not expected to grow. So if it's small network like, I don't know, home network or really small network, then it's okay, it's preferred because it doesn't expect to grow and we don't need to waste CPU cycles for dynamic routing. Routing to and from stub networks. A stub network is a network accessed by a single router, and the router has no other neighbors. For example, a stub network you can call like a home network. My home, your home, that's a stub network. We have only one neighbor, which is our ISP. We don't have any other neighbors. So our ISP will see our network as a stub network. Using a single default route to represent the path to any network that does not have a more specific match with another route in the routing table. What this means is that we can use a default route. Default route, for example, if we don't know how to send any data somewhere, we can just send it a default router or it's a default route. So for home users, for example, our home network the default route is our ISP. Anywhere we want to go to the internet, we first have to send it to our ISP. So we can create a default route pointing to our ISP. Static routes are often used to connect to a specific network. So for example, you're running the dynamic routing, but you want to create a static route for some network. There, we can use a static routing for that. The second, provide a gateway of last resort for a stub network. For example, like a stub network is our home network, and we can create a static route to provide a gateway of last resort. Like that will be our ISP. Reduce the number of routes advertised by summarizing several contiguous networks as one static route. So instead of sending, for example, I have a neighbor here, and I have 10 routes. Route 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Instead of me sending, okay, I got route 1, route 2, I got route 3, I got route 4, and so on, I can just say, okay, my neighbor, I have routes 1 to 10. That's like summarizing. You're sending to the neighbor, you're sending only one update instead of sending 10 individual updates. We will learn how to do summary in this lesson. And then create a backup route in case a primary route link fails. So for example, we have a broadband speed, a link towards another branch or internet, and we create a backup link towards the, like for example, like a dial-up. Just in case the broadband fails, we will use the dial-up. Okay, IP route command. This is the command to create the static route, so it always starts with IP route. First, you need to know that it's on the privilege mode. So first you need to know that it's on the global configuration mode, config, and the command starts with IP route, and then where are you going? The destination network address, that's a destination network address, and then destination network subnet mask, and then the exit. You're gonna send it to your neighbor's IP address or to your exit interface. So here we go. First of all is the network address here, this one here. The command starts with IP route. All the static routes start with IP route. Then we have a network address. This is destination network address of the remote network to be added to the routing table. So address. Subnet mask. Subnet mask is subnet mask of the remote network to be added to the routing table. So we have the network address and then the subnet mask. Then the IP address. This is referred to the next hop router's IP address, so your neighbor's IP address. This will create something called recursive lookup, because if I tell you, okay, to get to this destination you need to use this neighbor, what your router has to do is find out, okay, well, how do I get to that neighbor to start with? That will be the exit interface. Use the outgoing interface to forward packets to the destination network. You can choose either IP address, that will be the neighbor's IP address, but it will create another lookup for the router, or you can put your exit interface. Exit interface, there will not be another lookup. The router will right away will send any packets to that network through that exit interface. There's some networks that it's better to put IP addresses, and some networks it's better to put the exit interface. For example, if it's point-to-point network, then you will put exit interface. If it's a multi-access network, then it's better to put the IP address. Next hop options. The next hop option can be identified by an IP address, exit interface, or both, like we saw earlier. How the destination is specified creates one of the three following route types. So one of the three following static routes. So we have a next hop route. Only the next hop address is specified. And directly connected static route, only the router exit interface is specified. Or you can have a fully specified static route. The next hop IP address and exit interface are specified, both of them. So on our IP route command, if I do IP route, destination network, destination subnet mask, next hop address, it will be the neighbor's IP address, then it's next hop route. Or I put my exit interface, then it will be directly connected static route. Or if I put both, then it will be fully specified static route. Configure a standard static route with a directly connected static route. Okay, we have here router 1 that is connected to this network 192.168.3.0/24. It's got .1, the interface. Okay, and the PC here .10. So we're going to create this network, and in this network he's connected to another network or another router R2 in this network 10.1.1.0/30 through this interface, serial 0/0/0/1.1, and router 2 has got serial 0/0/0/0.2. Our network on the left here, if I go back here, our network is, because it's got no other neighbors and no any other path, is going to be called a stub network. This is a stub network as far as the R2 is concerned. R2 is connected to two networks. It's got one local area network, but plus it's got connection towards the internet. Local area network is 192.168.1.0/24, first IP address, first valid .1, and the PC is using .20. Okay, so what we're going to do here, we're going to create this network, and the router 2 will create a static route that's going to point towards 172.16.3.0. So router 2 doesn't need to use a dynamic routing protocol to reach 172.16.3.0/24. We'll just create a static route. Says R2 global configuration mode IP route 172.16.3.0, then the mask, and then its own exit interface. So serial 000. Okay, so I'll go packet tracer here, open. So I'll get a router. This is let me delete this router. So the next router will become router 1. Yep, that's what I want. Router 1. Router 1 is connected to switch. So let's get 2960 and a PC. Connect PC to the switch with a straight through cable because it's dissimilar device. So 10 here, and the switch to the router FA01 in there, and in the router FA00. So what we're doing is we are creating our ones local area network first. Yeah, so I can just click here and choose one color. I'm gonna just represent with this color. Okay, that's our network. This network is gonna be what do we say, 172.16.3.0/24. Okay, that's the network. So I'm just gonna check it. So 172.16.3.0/24, the router .1, the PC .10. So if I go to packet tracer, this one is gonna have .1, and the PC is gonna have .10. Okay, so I'm gonna configure the PC first, so that will be easy. Go to the PC, desktop, IP configuration, 172.16.3.10/24. So change that to 255.0, and then 172.16.3.1 for the router. Okay, the PC is done. Then I'll do the configuration on the router. I'm gonna do it on the notepad. So if I start a new one, so enable config t, and do the startup configuration. So hostname R1, enable secret class service password encryption, no IP domain lookup, line console sol 0, password Cisco, login exec timeout 00, and login sim. If you don't know any of these commands, I would advise you to check some of the startup CCNA semester 1 second video, I think. Then line VTY 0 to 4, password Cisco, login, exit, data, MOTD, authorized users only. Okay, and copy running config to startup config. Okay, so I'm gonna highlight all of this That's just the startup configuration, yeah? So copy, and I'll put it on the router. It says, do you want to start initial configuration? No. And I'm just gonna paste it here. So you can right click, paste, or click here, paste. I'll check there's no any errors. It's great. Okay, the next configuration, let's put a line here. They go to the interface FA00, IP address 172.16.3.1 with a /24, no shutdown. Okay, I'll need to do config T here. Okay, copy all that, go to the router again, paste all this. Boom. Everything is working, so check it. Show IP interface brief. Okay, so this side is done. What I'm going to do is I'm going to get another router for router 2, so get another router here. The second router is connected to another switch here on this side and a PC, and it's got say this connection towards the internet, so I'm going to write here one connection towards the internet here. That's my internet. Okay, here this connection towards the internet is going to be a loopback at 0, so loopback 0, and this connection towards the switch, so FA00 towards the switch, and this switch is connecting to the other PC. Those two, the routers between router 1 and router 2 is going to connect with a serial cable. If I try and use the serial cable here, well, we have a DTE and DC, so if I use a DTE here, I don't have any serial cables here. So I need to go to that router and actually add a serial port or serial interface card, wide area network interface card. Okay. First, before I do that, I want to save it, copy running config to start up, because I need to shut down the router. So you can't change the interface card if you don't shut down the router. So, okay, switch it off. Get one VIC-T here. I can use either one VIC or two VIC. It's either, it will be okay. I'm just using one VIC. And start. Go to router 2, do the same thing. So router 2. So go to the router 2 here. Zoom in a little bit, switch it off. Use one VIC-T and switch it back on. Okay. Now, the same configuration that I had earlier for router 1, I can do for router 2 here, the startup configuration. I'm just going to change the name, copy all this, and I'm going to paste it on router 2. So go to router 2, say no on the initial configuration dialog, and I don't need to type anything. I'll just paste it. Everything is working fine. So this configuration was for router 1. I'll do similar configuration for router 2 as well. Okay, interface FA00 that had 00192.168.1.1. So 192.168.1.1. No shutdown, and I'm going to use a loopback to emulate the internet. So IP address, say 1.1.1. No shutdown. You don't need to do no shutdown on loopbacks, but for some old routers you have to. So copy that, go to router 2, and paste. Okay, and show IP interface brief on router 2, and we can see we have a loopback here, and we have a fast Ethernet that's all up and working. And this PC, I'm just going to give an IP address to this PC. So go to desktop, 192.168.1. What was it? 3, I think. And then 192.168.1.1 is the gateway. Okay, so now they both have their own LANs, so we're going to connect those two together. We have to use a DC and DTE. One of the routers has to be a DCE. Since this is we are pretending to be the ISP router, let's choose that as a DCE. So serial 000, and this side serial 00. Hold on one second. It was serial 001. So I need to have another interface. Okay, one second. Go to this router. Shut it down first, and add one more VIC-T, and switch it back on. Okay. Now DC router 2, serial 000 and serial 10. Okay, fair enough. Then I'll put 10.1.1.0/30 on these two, and just want to say that this is the DCE and it will be .2, and this side here will be DTE and .1. Okay, now I'm going to configure the rest of the configuration between router 1 and router 2. So if I go to the notepad here, so router 1 interface serial 010 it was, IP address 10.1.1.1 and /30, so it's 252, no shutdown. For router 2, make some space here. Router 2, it was interface serial 000, IP address 10.1.1.2 in the end. And here we have to do the clock rate. Clock rate, so let's use 64,000, no shutdown. Okay, so I'm gonna copy this for router 1. Go to router 1. Okay, we have to make sure that we put the password now, because we shut it down. So the password is Cisco enable class, and config T to go to global configuration mode, and right click and paste. Okay, so now if I go to, I need to put this for router 2, copy, okay, config T and right click and paste. You can see this state has changed to up, so that's great, that's what we want to see. So router 1 and router 1 is up. So show IP interface brief. So you can see the interface 10.1.1.1, it's serial 0/01/0, it's got IP address 10.1.1.1 and it's up. Okay, this threw me a little bit. Why is it down? I thought I didn't configure it. Okay, config T, ping 10.1.1.2. Okay, can't do it here. I can do it if I write do ping. I don't want you to get used to that, so go to end, go to privilege mode and type ping 10.1.1.2. Yep, I got success 100%. Great. To check this PC, can ping the router or its gateway. So IP config gateway is 172.16.3.1, so ping that 16.3.1. Yeah, I can ping my gateway. Can this PC ping its gateway? IP config ping 192.168.1.1. Okay, great. Network is set up now. So this router 2 now, it doesn't need to have a routing table together with dynamic routing with router 1. So you can create a static routing. So in the router 2, we can say, okay, here. So I can go to router 2 and say IP route. When I want to go to 172.16.3.0 and the mask is 255.255.255.0, I can use my exit interface, which is all zeros. Not my neighbor's interface, my interface. So this will be like a locally connected static route. Or I can say next hop interface, which will be the neighbor's IP address now. So I can say, 10.1.1.1.1.1. But in this case I want to use my exit interface, so serial 000. You could use both. Okay, so I'm going to copy all that, go to the router 2, go in privilege mode first, show, to see the routing table, show IP route, yeah? And you can see that I have 3 networks. I'm directly connected with the internet, directly connected with my LAN, and directly connected with the here is the LAN, and here is together with router 1. So to point to the routers 2 network or local area network, to point to the routers 1 local area networks, I'm gonna paste that what we created. So paste IP route 172.16.3.0, and exit interface is my serial interface. So I can type end show IP route. Now you can see the code for static is S we have configured, so it's directly connected serial 0/0/0/0. You have to remember the static route is always administrative distance 1. No matter, even if you don't see it here, it's AD1. Directly connected route, the code is C, administrative distance for them is 0. Okay, excellent. We have done the static routing. We can't test it yet because router 1, the packets will go to there, but they don't know how to come back. So they have to know it both ways. We can try it in the simulation so we can see it. It would be great. Okay, so show no filters. I just want to show the ICMP. Here, I'm just minimize this a little bit. Okay, a bit more. Can we do a bit more? Yeah. Now the packets are going to go all the way there. Then they're going to come back up to this router, and this router doesn't know what to do with it, how to return it back. So that's why we can't have a successful from point to point. Okay, from one PC to another PC. So capture forward. You can see the packet is going to the switch. We haven't configured anything on the switch, so the switch is everything VLAN 1. Send it to the router. Router checks the routing table, finds out there is static route over there, so I'm going to send it to router 1. Router 1 sees that the destination is for the PC, so it's going to forward it towards the PC. The switch just looks at the VLAN, yeah, VLAN 1, boom, I'm going to send it to the PC. PC looks, reads it, says yeah, it's from me, I'm going to reply to it. So it's going to prepare a reply, send it again to the switch, and the switch is going to go to the router. But this router doesn't know how to send the packet back. So now it's going to be failing here. Here it's going to get stuck. So it's going to reply to PC1 and say, oh, no, I don't know how to get there. I don't know how to. So you remember this is a two-way. You need to know how to get there, and the packet needs to know how to come back. So that's why it's going to fail here. So later we're going to configure a default route for this router. So any packets anywhere, he's going to send it to router 2. Okay, so I'm going to make it bigger again now. Close this and go to real time. Excellent. If I go back to the slides, so now this we did standard static route. This is just some route. Exit is going to be directly connected. So directly connected static route. So exit, that's the exit interface here. Default static route. A default static route is a route that matches all packets. A default route identifies a gateway IP address to which a router sends all IP packets. It does not have a learned or a static route. So for example, our home routers, they all have a default static route, points to our ISP service provider. A default static route is simply a static route with all zeros as a destination IP address. So 0000/0 means anywhere you want to go with any subnet mask, I'm going to send it to my default route. So IP route, it says it starts with, well, we learned earlier, we said the global configuration commands, they all start with IP route, and we have 4 zeros here, 0.0.0.0. There is a small gap here, and then there's another 4 0. So these 4 zeros first are for the network address. The next 4 zeros are for the subnet mask, which means any subnet mask. And again, I have two choices. I can put my neighbor's IP address, or I can put my exit interface. So here, the first zeros matches any network address. These are the first 4 zeros. The second 4 zeros, they will match any subnet mask. And then again, my choice is IP address, referred to as next hop router's IP address, which means it's a neighbor's IP address. And your router needs to do a recursive lookup. Because if you say, okay, any network, any subnet mask, send it to neighbor ABC. Then the router needs to know, okay, well, how do I get to neighbor ABC? So that's a recursive lookup. The next one is exit interface. Use the outgoing interface to forward packets to the destination network. So just go out from certain interface. Okay, but you can use both. You can use IP addresses, exit IP neighbor's IP address, or your exit interface. So now we are going to configure router 1. It's going to say, okay, I don't need a dynamic routing for this network because I'm at the stub network. So what do I need the dynamic routing? There's only one path to go anywhere. So the commands to create the static route will be IP route, all zeros, and then the neighbor's IP address. Okay, so I'm using the next hop IP address on this instance. Okay, so I need to configure that. Open the packet tracer. So I need to configure an IP route for router 1. So if you see router 1, for example, see show IP route, you can see that there's nothing. He only knows what is directly connected network. So if I go to, well, let's just make it small separation here. Router 1. Then I'm going to create a static route. It says IP route, any network. These are my 4 zeros. Any network. 4 zeros. 0.0.0.0. Then another 4 zeros for any subnet mask. And I'm going to use my neighbor's IP address. So 10.1.1.2. Okay, that's all. So I'm going to copy this. Go to router 1. I'm in the router 1. So go to global configuration mode and say ping here. Oh, sorry, not ping. I'm not pinging it. IP route. Create a static route. Press enter. And show IP route. So now you can see that we have a default static route that points to any network with any mask. Administrative distance is 1. And the hop is 0 via 10.1.1.1.2. Sorry, administrative distance 1, yeah, and then metric 0. Now we have a static route that says the code is S, and there's this asterisk here is a candidate to be the default route that says any network with any mask. I'm going to send it to my neighbor 10.1.1.2, and the administrative distance of 1. Okay, so if we repeat the same what we did earlier, now the packets were stopping here. They failed. So what we're gonna do? We're gonna try another one and see if they can go all the way through. Okay, so if I go to simulation mode and minimize this so we can see it. Same packet, capture forward this time. Let's see what happens. Send it to the switch, router. Switch will send it to the router. Now the router has a specific network, which is 172.16.3.0. We'll send it to his neighbor router. The neighbor, okay, says this packet is going to my LAN, so it's going to send it towards the PC. PC is going to get the packet. Says, yep, it's for me. So I'm going to reply to this echo request. So I'm going to send the echo reply. Send it back to the switch. Switch, send it to the router. And now the router looks at the routing table and it sees that there is a default static route. So I say, okay, well, I'm going to send it to my ISP. And ISP is going to send it towards the router on the right. So this communication is successful. You saw how we created, it's going to be successful here. We saw how we created 2 different kind of static routes. First static route was we created, that was for a specific network, for this router towards that network. And then we created a default static route for router 1 that says anything, I'm going to send it to my neighbor. Okay, I'm going to move to real time now, and we go back to summarization. Summarization, route summarization, is also known as route aggregation, is the process of advertising a contiguous set of addresses as a single address with a less specific, shorter subnet mask. So like we said, I have a network 1 to 10. Instead of saying to you, I got a network 1, then send another one, I got network 2, I got network 3. I can just send you one packet that says, I got network 1 to 10. That's it. CIDR, or classless interdomain routing, is a form of route summarization and is synonymous with the term supernetting. CIDR ignores the limitation of classful boundaries and allows summarization with masks that are smaller than that of the default classful mask. This type of summarization helps reduce the number of entries in the routing updates and lowers the numbers of entries in the local routing tables. For example, say that we have these 4 networks: 192.168.0.0/24, 192.168.1.0/24, 2.0/24, and 3.0/24. We can send them to the neighbor one by one, or the neighbor can create a static route for each network, saying, okay, well, IP route this network, add this interface, and so on. Or the neighbor can just say one route, IP route 192.168.0.0, with this mask, send it out this interface. This will create the same summary route. Okay, so now we're gonna learn how to create these summary routes. So I'm just gonna open a notepad here. So we had 192.168.0.0/24. The second network was 192.168.1.0/24, and then 192.168.2.0/24, 192.168.3.0/24. Okay, so 192.168 is exactly the same for all of them. So 192 is 1100, 1234, 168.10, 10, 1000. That's 192.168. 0, 1, because when you calculate in summary route, you really have to put in the binary. Convert them to the binary. Okay, I just converted this 192.168 in the binary. Well, I didn't have to because they're all the same. All 4 networks are the same. So 16 bits are here the same. So what I need to do is think about the third octet, really, because there is the difference. They are starting to differ from each other. So 0 is 1, 2, 3, 4, 5, 6, 7, 8. And then the other zeros is another 8 zeros. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Here it's all the same. So I'm not going to write anything there. And then we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 here. The third network, again, I'm not going to write anything here because it's the same. The 2, if you convert it to binary, will be 1, 2, 3, 4, 5, 6, 7, 8. Sorry. How many bits we have there? 2, 4, 6, 8. Yep, this bit here represents 2. So 1 dot, and then we have 8 bits. Again, 192.168, and the third octet is where the things are changing. So 3 is all zeros, 1, 1. Okay. So now we have to think, okay, what bits they starting to change? Okay, let me just copy these. Just put them here. Because that's 192.168 for all of them is the same, yeah? Okay, so at what bit it's starting to change, the difference? So we can see that up to here, it's the same. For all 4 networks, they have this bit as well, the same. This bit, this bit, this bit, this bit, this bit. Up to here, all 4 networks are the same. Here are the differences starting. So I can just push them here. So I can say all 4 networks up to here are exactly the same. And I can count them. Okay. So that's 8, another 8, 16, 17, 18, 19, 20, 21, 22. There's 22 bits are exactly the same. So I can write /22. Then I have to, well, I can ignore the last ones. Yeah. So I just have to convert the bits that are the same into decimal. So that's going to be 192. And then I convert this into decimal. That's going to be 168. And I convert this into decimal. So that's going to be 0. And because I ignored the last bit, is 0. So that's what we said. 192.168.0.0/22.
So 192.168.0.0/22 is 255.255.252.0. Okay. What I want to do is I want to take another example. Say I'm going to take 192.168.1.128 and 192.168.1.129, 192.168.1.130, and 192.168.1.131. See, they have to be contiguous, yeah? Even if they're not contiguous, you can still do it, but it's not recommended. They have to be like contiguous. Okay, so what we have to do is convert all these into the binary, right? So I can ignore 192.168.1 because they're all the same. I don't have to convert that in binary. I already know 24 bits here is exactly the same. So I'll just convert them 128. So this is the binary bit now. 128 is 1, and the rest zeros, 4, and then 129, it's 1 there, 130, it's 1 0 there, and 131, 1 1. Okay, so how many bits are the same here? So I can see up to here is 24 bits is the same for all of them. 25th, 26, 27, 28, 29, 30. 30 bits here are the same for all of them. So I can just push these, boom. So 30 bits are the same here. 30 bits. So I can say /30 are the same. When I convert them back to decimal, so I could keep 192.168.1 dot. Now I need to make sure that I count this, right? So don't say 0, because that will be wrong. You still have to count the ones there. So that's 1 there, so that's going to be 128. So summary address for all these 3 IP addresses is 192.168.1.128/30. I see sometimes with my students they ignore, if there's 1 there, you can count that as a same, but you have to add that as well. Don't ignore that. Don't ignore the whatever you have there, 1s and 0s. Okay, that's your summary address. So floating static routes. Floating static routes are static routes that are used to provide the backup path to primary route, a primary static or dynamic route, in the event of the link failure. The floating static route is only used when a primary route is not available. To accomplish this, the floating static route is configured with a higher administrative distance than a primary route. So for example, I have here router 1 is connected to router 2 through serial 001, and then on the router 2 is serial 000. Then we have a backup route that points to the public switch telephone network, as in case the primary route or WAN fails. For example, if wide area network link towards router 2 fails, then we will use a dial-up link. But if these 2 links, they're using like a routing protocol like EIGRP or SPF or so on, the administrative distance will be 90. And if you use a static route that points this way, the administrative distance will be 1. So this router will say, okay, well, 1 is better than 90, so I'm going to choose all my packets to go through it here. So that's a problem. To create this, that's what it says here. To accomplish this, the floating static route is configured with a higher administrative distance than the primary route. So for example, you go to the router 1 and say IP route, default network, towards the router 2, for example, 10.1.1.2, going to a higher administrative distance, 245. So just remember that when you configure the backup route, it has to have a higher administrative distance than whatever routing protocol you are running. Configure a fully specified static route. For example, in a fully specified static route, both the output interface and the next hop IP address are specified. This is another type of static route that is used for older iOSs prior to Ceph. This form of static route is used when an output interface is a multi-access interface and it's necessary to explicitly identify the next hop address. The next hop must be directly connected to the specified exit interface. For example, in this case, we are using both the exit interface and the IP address of the next hop router.
To verify a static route, we did earlier, so we tested with the ping. Apart from using ping and traceroute, to verify it, we do show IP route. Or if we don't want to see all the routing table, just see the static route, we say show IP route static. Or if you want to see only individual network, then we say show IP route, then the network. The IPv6 route commands, most parameters are identical to the IPv4 version of the commands. IPv6 static routes can also be implemented as standard IPv6 static route, default IPv6 static route, summary IPv6 static route, and a floating IPv6 static route. The command starts with, well, in global configuration mode, IPv6 now, route, and the prefix, the network with destination network, and the prefix length, then the IPv6 address, neighbor's address, or your exit interface. Like for example, in this case, we have IPv6 route 2001 DB8 :ACAD:1://64 exit interface serial 0/0/0/0. The next hop up can be identified by an IP address, exit interface, or both, like same as what we said on the version 4. Next hop IPv6 route, when you identify next hop IP address, neighbor's IP address. Directly connected static route is when you identify the exit interface, or fully specified static route when you do the next hop IP address or the neighbor's IP address and your exit interface. To verify the IPv6 static route, similar to IPv4, show IPv6 route. Now instead of just saying IP, we say IPv6. Show IPv6 route static, or show IPv6 route network. Default static route. Default static route IPv6 commands. The default in IPv6 we just say : that will say all zeros /0, any prefix thing, and then again the exit interface or the neighbor's IP address. For example, : /0 matches any IPv6 prefix regardless of what mask they have. And then we talked about the IPv6 IP address and exit interface. Remember, when you do IP address, this will create a recursive lookup. Summarize IPv6 network addresses. Aside from the fact that IPv6 addresses are 128 bits long and written in hexadecimal, summarizing IPv6 addresses is actually similar to the summarization of IPv4. It just requires a few extra steps due to the abbreviated IPv6 addresses and hex conversion. Multiple static IPv6 routes can be summarized into single static IPv6 route if the destination network are contiguous and can be summarized into single network address. Calculating a summary route. For example, if we have these four networks, 2001 DB8 CAF0, CAF1, CAF2, and CAF3, :1://64, they all go into this router 1, and router 1 is not going to advertise them to router, to router 2 is going to make an IP route table. Instead of making 4 different IP routes, you can just summarize it into one IP route. So IP route 2001 DB8 CAF0 : //62 and S000. Okay, we're going to see in IPv6 as well how to create a static route. So let's just take some network. So 2001 DB8, what we had CAF0 : :1 : //64, and we have 4 of these. So CAF1 here, CAF2 here, and CAF3 here. Okay, so what we need to do, we can ignore these. This is called, remember, this was called a hextet, yeah? One hextet is 16 bits. One digit in hextet represents 4 bits. So that's 16 plus 16, that's 32. Plus 4, that's 36. That's 40, 44. So 44 bits are exactly the same, right? 44 bits are the same. So here's the difference. So one of these represents 4 bits. So I'm going to write it in like this. So 0, 4 bits. Then 1 is another 4 bits. 1. Then 2, another 4 bits.
How you represent 2? 1 0. And 3, we represent 3 like this. Yep. That's 0. This bit represents 1. This bit represents 2. That 2 there. And these 2 bits represent 3. That's those 3 there. So 16 bits are the same. Another 16 bits, that's 32. And 4, that's 36. And another 4, that's 40. And another 4 is 44. 44 are the same to start with. And then we have 2 bits. 2 more bits are the same. 44, 45, 46. So we can say 46 bits are exactly the same. So it will be 2001 db8 calf, and then we have to convert those two in decimal. So it will be 0. And then colon, that's it, 46. So out of these 4, we just said from 64 we went to 46 if we want to summarize those. Okay, let's take another example. I want to take one more example here. So say I give you 2001 db8 1 64 like that. Sorry, 64. And then again the same one. Here we have 2, and we have 3, and here we have 4. Okay, so when I convert this, now you know the compression, the leading zeros are gone, yeah? So we need, let me just write those as well. So don't want to compress anything. So 2001 db8 is actually 0 db8. 1 is actually 0001, and colon 64. The next one is similar, but here's 2. So this represents 4 bits here. So 2 here. I'm just removing the compressed 3 and 4. Right. Now, the difference is here. Again, we have the same thing. So we have 16-bit, 32-bit, and 4 36, and 4 40, and 4 44. 44 bits are the same. So here we have 1, for example, it represents the same we had earlier. So 0001, that's 1. Let me write here. So 2 is 1 0, 3 is 1 1, and 4 is actually 1 0 0. That's 4. So in here we have, how many bits are with the same? So again we said 16, 32, and 4 36, and 4 40, and 4 44. Plus how many bits are here? So 44 and 1 45. It's actually 45 bits are the same. And we're going to convert this back to decimal, ignoring everything behind. So we just add this. So 2001 0 db8, and say all zeros. So 1 0 0 0 0 45. So I can really just say it like that. 45 bits. Troubleshooting a missing route. Same with IPv4. With the troubleshoot, we use ping, traceroute, both for IPv6 and IPv4. Ping, traceroute, show IP route. For IPv6 will be show IPv6 route, show IP interface brief, and show CDP neighbors. Okay, thank you very much for watching. Please have a look at other videos that I have, and don't forget to subscribe. It was me, Astrid Krasniqi. See you. Bye.